Most adults were taught how to subtract at school using rote learned methods. For many, it remains a mystery, and their inability to subtract easily undermines their confidence with any numeracy. In this video, we use hands-on materials to revisit common methods of subtraction so that they do make sense. The benefits of using hands-on materials in numeracy teaching was discussed in another video in this series, Using Hands-on Materials, Making Sense of Fractions. The hands-on activity you will see here began by asking participants to do a subtraction using a formal method. By formal, I mean one that they were taught at school, a pen or paper type of method that you would have learned and practiced over and over again in school maths classes. But also, sometime before this, the group did some in-the-head calculations, one of which was to calculate the change they would get if they gave a $5 note to buy a chocolate bar for $1.45. You'll hear this referred to in our discussion. Just think about, just for a second before we get out the hands-on materials, how could you explain to somebody how that method worked? So I can hear things like, what are you borrowing? Why are you borrowing? Where did it come from? How can you move them around? Did everyone manage to do the calculation accurately?
We've got 3 methods on this table.
3 methods. So which are your 3 methods?
2 of us have got 1 method, so you can't take 5 away from 0, so you borrow from the next column. There's nothing in the next column, so you need to go to the next column. So the 5 is crossed out and becomes a 4, and you add 10 to the 0. Then you cross the 10 out and make it into a 9 and add your 10 into the first column. So then you can take 5 from 10 and get 5. You can take 4 from 9 and get 5, and you take 1 from 4 and get 3.
So you wanted to borrow from here, but there was nothing here?
Yep, so I went to the 5, cross that out, make a 4.
Crossed it out.
Add my 1 to the first 0, the middle 0 next to it, so that it looks like a 10. And then I need to still borrow, so I cross that 10 out and make a 9. And I add my 10 to the first 0, and now I can do it.
Now we finally can say 10 minus 5.
5 is 5. Yep. 9 minus 4. And 4 minus 1.
Is that correct? Yes. How would we know if it's correct? 5 and 5 is 10. 6 and 4 is 10. 4 and 1 is 5. Yes. Okay. Now, did you have a different method?
Well, I was going to say, no, I had a similar written method, except I went 491 because I knew how to keep going. But to be perfectly honest, before you said you've got to do it that way, all I did was go 500 take 100 is 4, take 40 is 360, take 5 is 25. And I got there an awful lot faster than borrowing.
Absolutely, you got there. Do you recognise that that was one of the questions I asked you last time? It was if you bought something for $1.45, how much change would you get for $5?
Oh, yeah.
And nobody would have done that to do it, because there is a much easier way to do that than to go through formal school methods. And yet, in school, we have asked people to do this. So anyway, what I want to do is introduce the whole idea of subtraction for those of you who have a need to teach people who want to use formal methods of subtraction and how to make that method make some sense to them. So that's basically what we're doing at the moment. But yes, I wouldn't say, and I wouldn't ever advocate to anybody to do that in using a formal method when you can count on so easily. I am going to introduce you to my improvised learning materials. We have a board with hundreds, tens and ones. And what I want you to do when you get that and get the package of straws is to tip it out and have a look at what's there. The gorgeous thing about straws is they're light as a feather to carry around. They're not weighty, and they aren't something people used in school. even though these ones from the supermarket are very brightly coloured and muted, could be better. You've got ones, live in the ones, tens, and bundles of, what's in here? 10 lots of 10, so it's 100 and they live in there. You've got lots of digits to move around and rubber bands in case you need to bundle anything up later. Again, when you're introducing these to adults, make sure you're very sensitive about why you're doing it, and it's really best to do them at the moment when they need the subtraction. Take all the rest of the things off, and we're just going to model what 2 would look like on the board. Okay, and what would 20 look like? 20. Okay, so you've got 2 in the 10s and nothing in the 1s, so we've got 20, and then 23. And what about 103? 103. Before you introduce this to your students, you might want to get them to think about why 10. I'm sure that our number system got based on 10 because of these 10 digits on our hands, and that was our counting method. And once we run out of them, we're going to have to go somewhere else or make a mark on a page. And it is a cultural system, and that's what we're teaching to students too. Not because everybody uses it or everybody always did, but this is the one we've got. So as soon as we've got 10 of these, they get bundled up and they go to live somewhere else, because once there's 10, they can't live in there anymore. So only up to 9 of them can live in this singles column. After that, we've run out and we move them on, but we bundle them up. So we carry them across. Okay? And what happens when we get 10 groups of 10 in here? We bundle them up and they turn into hundreds and they move across. We carry them across. So we're getting this idea. So what if we add 35 and 16 with the straws?
And you go. There's 35.
And now we need 6, don't we?
And 10. And 10.
So,
and now we've got a problem, haven't we? Because she's just told us you can never have more than.
so you've got to get.
So we need to bundle and move.
Do you want to
across.
just? Oh, you want to bundle them. It's going to replace.
I like your strategy.
You like that one? Pre-bundled.
Except some students would struggle with that.
They would
but
struggle.
Yeah.
I think you would get them to bundle.
So you can see how addition works. It's quite simple. There is a game that you can play called 36 involving dice and throwing the dice until you get to 36, which if your students need to do a lot of practice with that, it becomes a game, so it becomes competitive, and they do it in pairs. And that's a good thing, because then they get a chance to practice bundling and carrying, and also calling out numbers and explaining to each other what they're doing. So that's a really good way to get them familiar without making a big deal of it. Okay, now what about subtraction? I want you in your groups to use the straws to demonstrate these.
1, 2, 3, 4, 5, 6, and 10. Take it away.
To take away, we just remove. So that's easy, straightforward. Now the next one, 30 minus 16.
So you need to make that 10 and that 2. Now you can take 6 from there. Yeah, so you can take 6 from there now.
Down differently.
Yeah, I mean it's the same process. So in essence, I've moved them across, haven't I? By making 30 minus 16, by making this now 10. So then I've still taken the 6 away, and then I've got 3 minus 2 because I've made it into 2. So now I can do that with it under my method of subtraction.
So the pen and paper version of the subtraction we just saw would be written like this. Because you can't take 6 away from 0, you need to get 10 from somewhere else. As we saw, Jenny took one bundle of 10 into the ones column, leaving 2 in the tens. On paper, you change the 30 into 20 and 10, writing it like this. Then you can subtract the 6, leaving you with 4, and then one bundle of 10 was taken from the 2 bundles in the tens column, leaving 1 behind. So the result is 1 bundle of 10 and 4 singles, or in writing, 14. That's basically how kids in school are being taught subtraction, except that what they use is the blocks. And the advantage of the straws, I have to say, is that when you decompose, you are not whipping one thing away and changing it into others. You're actually decomposing the bundles to become bundles of 10. There's a little bit of sleight of hand with MAB blocks, because suddenly this big block is changed into something else that's a completely different animal and put on the thing. So with the straws, or you can use icy pole sticks if you don't want to use brightly coloured things, by the way. Or if you can find plain straws, they don't have to be brightly coloured, and plain buff manila folders, but there's a story there. Okay, so this is why, in fact, schools changed to this method, because they thought that students would understand it because it was a seeable method. I do and I understand. They will be able to see this and they will be able to understand it. Yes, but it gets very messy at times, and so it's, I don't know whether the baby went out with the bathwater there or what, really. The borrow and pay back method, probably nobody really knew why it worked, but it was simpler. To illustrate the borrow and pay back method of subtraction, I'll start with the simple example 30 minus 16 that we saw illustrated with the straws, using what we call the decomposition method. Now first, I can't subtract 6 from 0, so I borrow 1. Now 6 from 10 is 4. Then I have to pay back my 1, which I do here. Now 1 and 1 is 2, and finally 3 minus 2 is 1. I should check this, so I add the 14 and 16, which fortunately does get me back to 30. This is how 500 minus 145 would look. 5 from 0 you can't do, so I borrow 1 and put it here where it makes 10. Now I can say 5 from 10 is 5. Now I have to pay back that 1 I borrowed. I put it here. And so 4 plus the 1 becomes 5. Take 5 from 0, I can't do. Again I borrow 1 and put it here, giving me 10. So again, 5 from 10 is 5. And pay back 1. I put it here. Finally, 1 plus 1 is 2, and 2 from 5 is 3. It's always a good idea to check any subtraction that you do, so let's do that. If I add this 355 to the original 145, I should get back to 500. As I said before, this method was discarded because it wasn't easy to see the reasoning behind it. But it can be made clearer if we think about it. When I borrowed the 1, what I really did was add 10 to the top line. So 0 became 10. Then I paid it back. I really added 10 to the bottom line. So the 10 of the 16 became 20. So to get my answer, I've in fact added 10 to the top number and 10 to the bottom number. In other words, both numbers became 10 more than they were. To understand why this is okay or legitimate, I'll quickly demonstrate something to you with the help of 2 volunteers. Keep in mind that when we subtract, we're finding the difference between 2 things. If we look at these two, the difference between their heights is about 29 centimetres. Now I'm going to ask them both to stand on this platform. I'm adding the same amount to both their heights. Will this change the difference in their heights? Clearly not. So as long as I add the same amount to both numbers, the difference will stay the same. For many adults, this demonstration and time to play around with the straws themselves can be very helpful in unravelling the puzzle of the rote learn methods from school, thus making a lot of sense of a mystifying topic. This is especially useful for parents who want to understand what their kids are learning, and for the literacy and language teachers who they might ask to explain it. Sometimes, though, it can be better to show students a completely different approach, that of counting on. Counting on is very like the old-fashioned method used by shop assistants to give you change, that is before computers took over at the cash desk. They used to count out change into the customer's hand. To illustrate, let's go back to the $5 note given when buying the $1.45 chocolate bar. Beginning at $1.45, the shop assistants will first give you 5 cents, saying $1.45 and 5 is $1.50. And then 50 cents, saying and 50 is $2. Finally, she would give you 3 more dollars, saying and 3 is $5. This can be represented very simply like this. This method is effective for any subtraction at all, especially for students who have struggled in the past with decomposition. I find it particularly effective for calculations with time and distance. Further information and loads of student practice examples can be found in Building Strength with Numeracy, the online resource from Velbeck.